Happy holidays, dear listeners. I hope you had a great year behind you and are fully ready to start 2019. We have our news mini section as a routine. Professor Haluk Aaron has reviewed a book about electric vehicles, business model, and in addition he has chosen an outstanding PhD thesis to review. It's about developmental methodology for the evaluation of active safety using the example of preventive pedestrian protection. This is Mariam Kaveshkar and this is the news mini section of episode 50 to start the year of 2019. Last March, Uber was blamed for the crash that caused the death of a passenger. This was followed with halting the tests in Arizona and Pittsburgh and its permit left to expire in California. Uber fought a lawsuit with Waymo. It was a difficult year for driverless cars of Uber. But close to end of the year, Pittsburgh allowed Uber back on its roads. Now, they will operate in drastically reduced speed of 25 miles per hour and less challenging environments. There will be 2 drivers in the car to take control in case of emergency and no passengers, only on weekdays and only in daylight. Waymo has the highest number of autonomous road traveled so far, 8 million miles on public road. It used its experience and authority to service people, solving transportation problems for people with disabilities, transit employees, and families. However, the winner of the race last year were not these companies, but slow buses. The driverless shuttle popped up in university campuses or tourist routes. Maybe the novelty of using them would change the mind of people about driverless cars and autonomous driving. In October 2018, the U.S. Department of Transportation informed that it will rewrite the safety rules for car makers. Now in Arizona, in the U.S., the Kroger's supermarket will deliver the groceries by driverless shuttle to the customers, only for the radius of 1 mile, but however, this is a big step to implement this technology into everyday life. Kroger had launched a manned autonomous car with a company called Nuro in August, but the new idea of a car with no driving pulling up next to customer's house is a thrilling sight for residents of area. The autonomous car called R1 has no steering wheel and no seat for passengers. Customers place an order on their smartphone or laptop and get a text message when the groceries are on their way. Another message will alert them when the delivery is curbside. Once the vehicle arrives, the customer will receive a code to punch in to open the doors. Giannuati said, Corporate Affairs Manager at Cincinnati-based Kroger's Fry Division. Although this vehicle is unmanned, but for early stages, a so-called shadow car will follow it to stop and control it. Since R1 is unmanned, it will prioritize the safety of pedestrians and other vehicles. Still, there are major challenges in front of the development of this type of transport, among them weather and state laws, which both of them are mild and predictable in Arizona. Let's switch to other side of the globe, the subcontinent India. This country has 400 fatalities on road caused by accidents per day. Most of the developing countries have taken major steps to alleviate fatal human loss, but India still has to catch up. Using the same dataset which helped in developed countries to tackle challenges like cityscape won't help in a place like India, where traffic laws violation is rampant. This data is not just about lane direction and crossroads, but it has to consider the behavior and driving habits of Indian riders. This is a project funded by Intel in partnership with the government of Telangana and Karnataka, along with the team from IIT Hyderabad. The team created about 10,000 pixel-level annotated images and 50,000 object-level annotated images, twice the size of Germany's cityscape, which contained 5,000 frames. For fine annotation, they used the forward-facing cameras of a stereo pair. These images were then sampled from the video feed with more attention laid onto traffic junctions and other crowded portions. Experts predict an autonomous intervention in this sector by 2025, For India to keep up with the pace, it needs to prepare the roads, fill the potholes, intensify the research, and be ready to deploy when the advancements have reached maturity. With all this news, 2019 should be a very happening year for intelligent transportation and in detail for driverless cars. GM announced this week it will free money for investing in such self-driving technology by shedding thousands of jobs and halting production in 5 North American plants. This decision was not welcomed by some authorities. Waymo has been testing Chrysler Pacifica minivans outfitted with the technology since 2016, and Fiat Chrysler previously said it was providing the company tens of thousands of vehicles in advance of the launch. Ford is currently testing autonomous technology in its mid-size Fusion in few cities such as Detroit area, Pittsburgh, and Miami, and is planning to start the testing in Washington, D.C. in early 2019. The car maker has pledged to invest $4 billion in its autonomous vehicle units through 2023. Toyota announced it would invest $500 million in Uber, and its Sienna minivans will be equipped with Uber's technology for use in a ride-sharing fleet. Uber expects to begin receiving shipments in 2019 of the 24,000 self-driving sport utility vehicles that it ordered from Volvo. Elon Musk, the billionaire inventor, is confident his company Tesla will be the first to perfect a fully self-driving car in 2019. Let's stay tuned and see what the year 2019 will bring to us. Now let's listen to Dear Haluk reviewing a very interesting book, Electric Vehicle Business Models, Global Perspective, edited by David Beaton and Greron Mayer.
This is the book review section for ITSPodcast. Read by Dr. Haluk Eren, Fırat University, Elazığ, Turkey. The book title is Electric Vehicle Business Models, Global Perspectives, and consists of 271 pages. Produced by Springer in 2015. Edited by David Beaton and Gerion Meyer. Nowadays, electric vehicles are becoming de facto global technology. That's why countries in the world have already begun to face environmental, energy security, and health issues as a growing number of electric vehicles. Meaning, governments and industry have to take into account the challenges and opportunities of this technology. As a result, this emerging global phenomenon needs contemporary sociology, innovative technologies, effective policies, and new business models. This book gives global insights that provide expert comments and analysis to citizens, administrators, and researchers through quality articles on electric vehicle business models. It provides information throughout the worldwide network of organizations about technologies, consumers, products, and services that encompass the electric vehicle ecosystem. Electric mobility products and services provide numerous benefits, meaning the goal is to make electric vehicles more cost effective, convenient, desirable, and rewarding to use, with relative advantage of fossil-fueled vehicles. The present book consists of 5 parts. Part 1 mentions about industry perspectives. The right business model is rarely apparent early in emerging industries. In addition, customers and building industry players often face many restrictive forces and change costs to adapt to new technologies or ways of doing business. Therefore, the current chapter suggests that business model innovation will facilitate the further adoption of electric vehicles in the market. Part 2 introduces business models for recharging infrastructure. This includes market models and billing strategies for public charge points, the business case for deploying rapid charges on a motorway network, and solutions for residents of multi unit dwellings. Wireless charging technologies and the related potential business models emerging for this new technology are also discussed. Part 3 elaborates energy systems, which are considered from two perspectives. The first is the potential to integrate electric vehicle batteries with the grid to provide dynamic storage and supply. The second one concentrates on the vehicle itself, taking into account how vehicle design and battery systems influence energy efficiency and total cost of ownership. Part 4 pays attention to fleet applications of electric vehicles, as discussing the challenges, opportunities, and the evolution of electric mobility in car sharing business models. It then provides an example of how fleet managers can use analytical tools to determine the ways in which electric vehicles significantly reduce money and emissions. The final part of the book introduces case studies on the different aspects of electric vehicle business models in the world to expose lessons and conceptual predictions from experience in Japan, China, Hawaii, and Chile. Most new business models emerge from motivation of lessons learned. Therefore, we hope that readers will find the evaluations in this book useful and inspiring to initiate multiple initiatives that will accelerate the global distribution of electric vehicles. The target audience of the book includes primarily practitioners and decision makers, but it can also be useful for researchers, professionals, and graduate students.
Thank you, Haluk. As you know, and I mentioned, Professor Haluk Aaron has reviewed a well researched PhD work in this episode. With this hope that it motivates PhD students and their supervisors, exposing outstanding PhD research, as well as associated university administration and hosted researchers.
The second round of the book review is a recognized outstanding PhD research. The related book title is Development of a Methodology for the Evaluation of Active Safety using the example of preventive pedestrian protection and consists of 195 pages. Produced by Springer Thesis in 2015, written by Thomas Helmy and supervised by Professor Foyka Schindler. Recently developed driver assistance systems present a significant contribution to traffic safety. However, their influence on accident avoidance and mitigation is related to their conception, technical capabilities, design, and subsequent integration, as well as traffic, environmental, and individual factors. Thus, an overall assessment of the performance of newly developed systems is necessary. This thesis introduces a new methodology for optimization and evaluation of traffic safety, which simulates the processes involved in traffic conflicts using dynamical, human, and technical models, evaluating active safety systems like vehicle based preventive pedestrian protection. The models comprise human cognitive functions and responses, the responses of an active safety system, and the interactions between the human and the system. The thesis consists of 7 chapters. Chapters 1 and 2 describe participants and interactions of road traffic and the occurrence of an accident. It then summarizes the state of the current scientific and technical knowledge related to evaluation of active safety using controlled experiments, natural driving, and accident data, as well as test procedures and assessment metrics. Chapter 3 and 4 introduce a new approach to evaluation of active safety, accident scenarios, configuration of a functional demonstrator of a preventive pedestrian protection system, and a simulative technique are described in detail. Then it's given methodological research on driver behavior in response to a preventive protection system through driver interviews and ratings. The main goal of this experiment is to use realistic parameters for this scenario by means of a dynamic driving simulator. Chapter 5 gives the development of injury probability models using empirical accident data. The related statistical methods and the models are discussed in detail. The methodology and developed models are given for the injury severity score and fatalities as outcome categories. Chapter 6 illustrates the results of the described evaluation method using different configurations of a preventive pedestrian protection system. The findings are interpreted with respect to the methodology. Metrics and processes necessary for system optimization and evaluation are discussed. Chapter 7 finally provides a discussion of the approach, results, and the conclusion. This thesis suggests practical solutions for active safety systems. It can be useful information for developers in traffic safety, researchers, professionals, and all stakeholders, including policymakers and consumer advocates.
Thank you, Haluk. Dear listeners, let me wish you a great year ahead, successful and joyful. Don't forget to share and subscribe and check out our other media for other news. This podcast is sponsored by IEEE Intelligent Transportation System Society. This was Dr. Mariam Kavishkar from IEEE ITS Society.